Hello students, welcome back to this interesting chapter, Chemical Kinetics. In this module, we will understand another numerical based on the relationship between K1 and K2 at different temperatures. You can even try and solve this on your own if you've understood the previous module. What is the activation energy for a reaction whose rate constant doubles when the temperature changes from 30 degrees Celsius to 40 degrees Celsius? So here, if you read this question carefully, you will know the given data, which is at lower temperature, T1. The temperature happens to be 30 degrees Celsius, but you have to convert it to Kelvin. So that becomes 303 Kelvin. You also know that the rate constant has some value. Now that value has not been specified, but we have been told that the value of this rate constant doubles when you increase the temperature. So you take this value K1 as K. At a higher temperature is obviously 40 degrees Celsius over here, but again converting it into Kelvin, we will get T2 is equal to 313 Kelvin. Now here the value of rate constant has to double, which means that our K2 will be twice of K1. So I can write it as 2K. This is the given data to us. And once again, we have to find the value of activation energy, EA. So in order to find our activation energy, in order to get the solution, we first have to know the formula. We know that log of K2 upon K1 is equal to EA upon 2.303 R into T2 minus T1 upon T1 into T2. That's the formula with which we even solved one numerical before. So once again, let's write down the formula in terms of EA. So EA is equal to 2.303 R into T1 T2 upon T2 minus T1 into log of K2 upon K1. So this is the formula in terms of EA. And when we substitute the values of T1, T2, K1 and K2, once again, we can do that. So we'll get EA is equal to 2.303 into 8.314 into T1, T2 upon T2 minus T1. So we can write it as 303 into 313 upon 313 minus 303. Once again, you can see that the higher temperature is T2 into log of K2 upon K1, which is 2K upon K. Now here, as you guessed it right, K and K will get cancelled and we will be left with log 2. Again, when you solve this equation further, you will get EA is equal to 19.147 into 94839 divided by 10 into log 2. Now, I'm sure you all remember the value of log 2 by now. So you solve this log and solve the fraction, and then you can rewrite the equation in this way. Again, when you solve this, the final value of activation energy will come out to be 5.4658 into 10 raised to 4 joules per mole. Once again, if you want to write it in terms of kilojoules per mole, you will have to multiply it by 10 raised to minus 3. So when we do that, the value of activation energy will become EA is equal to 54.658 kilojoules per mole. I'm sure you remember the unit by now. Alright? So I'm sure you've understood how to solve these kind of numericals. That's all for this module. Till then, you take care.